This video will show you how to use the pH of a weak acid and find the weak acid's concentration. Once again, we use the Ka expression, which is provided on the resource sheet, and you will need to rearrange it in order to make it subject to the weak acid concentration. Notice though that it has been manipulated so that once again we've used the assumption that the concentration of the hydroniums is going to be the same as the concentration of the conjugate base. So that's where, if you look at this, we have substituted hydronium for the conjugate base there, which is where the hydronium squared has come from. And then it's just simply rearranged so that it's subject to HA. So it becomes hydronium squared, because we've replaced the conjugate base, divided by Ka. So if I was to not learn this formula that this iPad gives, because it's not on the resource sheet and I'm not good at memorizing things, then this is the steps that you would take. You would write out your Ka expression, which is on the resource sheet, and then you rearrange it to make it subject to the acid, hence concentration of HA. Some questions, they'll give you the Ka, which makes it relatively straightforward. Other times they'll give you pKa, in which case you'll need to convert it back to Ka. Now, you will need to find the concentration of the hydroniums. They will give you the pH value, so you'll use the inverse log negative pH to do that, and that will give you your hydronium value. And then it's just a case of substituting it into this equation and the job is done. Let's do an example. So this question has got hydrocyanic acid with a pH of 5.23, and they've given us our Ka value. So starting off, I would write my weak acid partial dissociation equation and then give myself my Ka expression. From there, we are going to replace the conjugate base with the hydroniums because their concentrations are assumed to be equal. And I've rearranged it so it is now the concentration of the weak acid is the subject to hydronium squared over Ka. Now, the pH was given to us as 5.23, so to find that value for hydroniums, I need to do inverse log, which negative 5.23, so that's the negative pH value, and that will give me my value for the hydroniums at 5.89 times 10 to the minus 6. Then it's just a simple case of substituting that value in, squared over the Ka, and then we've got the concentration of our weak acid, and the job is done.